So the table of contents for our representation including production, the sensitivity and population, and for the methodology, we will be talking about data collection. This is context for study data and data analysis. And for the conclusion, we will talk about the goals and research. So let's talk about suicide. Suicide is a death caused by self-directed injuries to nature with the intent to die as a result of the behavior. And suicide is a symptom of an atomic suicide. So suicide affects from after the individual has taken his or her life. So some facts about suicide. Suicide can occur during death among teenagers, and it may last approximately for their ages. A person who struggles with suicide needs to find and go conclusions of family members and friends. Suicide rate is increasing throughout the year. Many people are living suicide. So there are many factors that are possible in suicide. Some examples include stress, mental disorders, quality of life, school year, and family. The factors and population demographics may vary in different countries. For example, in South Korea, they see that people in their 20s are the main group that conduct suicide due to stress from education and work. Meanwhile, in America, depression affects up to 20 to 25% of Americans ages 18 and above in a given year, leading to suicide. Therefore, we came up with a program to study the relationship between microfactors and suicide rates in different countries. The purpose of this study is to study about the factors that affect suicide rate in each sample country and to further develop and apply uses in other countries in order to prevent or reduce suicide. So why should we study about suicide in these factors? According to World Health Organization, suicide is recognized as a public health priority. Around 800,000 people die due to suicide every year, and 79% of suicides are low and including So, however, suicides are preventable. First, we can analyze the factors that affect the suicide in order to develop or strengthen comprehensive suicide prevention strategies. The scope and limitation for our study is that we will use the macro factors only, which include total average years of schooling, life satisfaction, and etc. And we will be comparing from the years 2005 to 2017, comparing 65 countries worldwide. And for our data set, we may not be properly merged together since we took the data from different resources.
So for the second one, methodology. For the first one is data collection. For the data collection, we chose the relative factor that might affect the suicide rate in each country, such as chronic disease, average total year of schooling, life satisfaction, average announced working hour, mental and substance use disorder, and so on. So next, when we include this data in the suicide rate into table program, it will match annual function is used in finding the same variable among the factors in analysis. So the next possible factor to be used, which are data itself in the same year and the same countries. So finally, there are only three factors that we use to analyze this suicide rate, which is life satisfaction, average announced hour working, and the last one is mental and substance use disorder. Student 205 to 217.
So after we figure out the same data from two data sets,
We are next going to explore the data and we do data visualization and analysis by plotting graph and then calculate correlation by this formula. And X is the mean of each vector rate and Y is the mean of each rate. And but actually we use Excel to have a calculation. And here are the results of plotting graph and correlation. As you can see from the graph, mental and custom use disorder have a high negative correlation, which is minus 0.8601, while others are approaching 0. In this case, we assume that mental and custom use disorder may affect the suicide rate. That could go deeper in data analysis.
Okay, there are multi-dimensions reduce it to be visualized by dimension reduction with the DTA method. The factors to reduce include suicide rate, life satisfactions, average amount of hours working, and mental and substance disorder. From 65 countries during 2005 to 2007, by using pattern and only one-stop solution. Next, the second method is clustering. After the data was reduced and left with two dimensions, next we cluster it into groups of countries with mean that shows in the top right, and number of groups that fits the most is 4 groups of countries. And for the bottom left is 4 groups of clusters. The y-axis of each cluster mean the amount of data, and the red dot lines show the average. Closer to 1 is better. Its mean points of cluster is far from another points of cluster in this same way. From all of number of groups, 4 clusters score at 0.4518, which is not the highest number, but we choose this group to analyze. After the data was clustered into 4 groups, each group must explain the characteristics of the groups by finding the average atomic vector of each group. The x-axis indicates the groups of countries regarding the number of suicide. The countries in group 0 are those who lowest suicide rate, and countries in group 3 are those who have higher suicide rate. And the y-axis suicide rate per 100,000 people, and mental disorder is per 100,000 people. Next slide. This slide refers to the last slide that we have for clustering. As you can see, for the mental disorder factors, the first line, the first row, we can see the country in cluster 1 and cluster 3, such as Colombia and Taiwan, has lower number of people with mental disorder, but high suicide rate. On the other hand, countries in cluster 2, like New Zealand, have more people with mental disorder than cluster 3, but the suicide rate is lower. For the second row, for life satisfactions, the data in cluster 0, 1, and 3 are spread evenly. For cluster 2, such as Denmark, Finland, the data is concentrated, showing that people are much more satisfied with their life, but still suicide rate is more than 10 million people. For working hours, the third line, the third row, for working hour, countries such as Myanmar, clustering 1, has high working hour, but it's still not much effect to suicide compared with cluster 2 that are lower working hours, such as Germany and Denmark. Here's the graph that concludes all the 4 clustering. Next, conclusions. We would say that there is no relationship but negative correlations. After analyzing the factor, we can conclude that the macro factor we choose has no relationship with suicide rate. The reason being is because the correlation between the three factors and suicide rate are all negative, meaning that our value will decrease as the other decrease. For example, the higher the number of people with mental disorder, the fewer the suicide rate. Moreover, the average cluster factor illustrates that despite the amount of suicide, the factor has similar contributions to it. For instance, as we can see from the average cluster factor, group 0 has the lowest suicide rate. However, all three factors has consistently a high amount compared to other. There may be other factors that we did not choose to analyze which affect the suicide rate, such as difference in social culture. Suicide still remains a taboo subject for some, especially developing countries. This may allow prevention of suicide to restart since this taboo has not been addressed. This country may include India, Brazil, and many more. Furthermore, there may be other methods that work better and are more precise than killing and cluster analysis.
Firstly, it is hard to find information because the project rely on many variables, meaning that there are many variables that could affect the project implementation. The struggle factor in the project was the unmatched data. Some data sets have the data itself in 1989, but some data sets don't, which our project needs to use only the matched data. Also, in the same way with the country and each factor variable. So the more factor we add, the less data left. Another big obstacle for us is that the results are not the same as what we expected to be. We expect that each macro factor will clearly have a correlation with the suicide rate, but actually it is just a negative correlation, which is again other previous. For the future research, we will focus on research more on micro factors such as prior suicide attempts, misuse and abuse of alcohol or other drugs, mental disorder, especially depression and other mood disorder, access to lethal means, knowing someone who died by suicide, in particularly a family member, social isolation, chronic disease, disability, and lack of access to behavioral health care. There is also a risk factor which are vary by age group, culture, sex, and characteristics. As an example, race, prejudice, discrimination such as family rejection, bullying, or violence, which often happens among LGBT youth. These factors are harder to analyze but we want to be more. Thank you.
Okay. This is a bit early, but you guys can start. Okay, you have 6 minutes, 5 minutes. Which team is this? Moneyball, okay.
You mentioned that what do you think will be a
There are other ways to we can use the micro factor argument. The micro factor is is the individual research that each people have alcohol or no alcohol or is that people satisfied how much they're satisfied in that the micro factor. So we could change in that way. It can be the same in the micro factor, but
Yeah. More from other things. Okay, very good. I'll make the comment, wrapping comment for everyone again. To make it a 200 instructions. Next up is kaleidoscope. Kaleidoscope, you are. โอเคครับผมมือเพื่อนๆด้วย
Morning, everyone. Welcome to our IMD.
About this project. This project is about exploration, visualization, and analysis of the very update of the IMDB asset. And the reason we do this is because we want to analyze all the images.
So our objective is to now analyze and visualize the IMDB data set. The number of produced movie year and what are the effect of COVID-19 on ranking of the movie genre was from the average IMDb rating, the top 5 rated genre in 2015 to 2019 compared to the top 5 movie genre in 2019 compared to the and the overall effect of COVID-19 on the number of movie produced, number of moving, profile, rated genre, and profile genre which are produced.
So the reason we chose this topic is because we have been very interested in about the movie industry, and also we're related to our so moving on to the data set and so the data set that we're taking from is from the IMDb website, and basically the reason we chose this one because it has a wide range of movies, and every movie that is listed on this website can be used. Also, we measure daily or marginal daily. The data that we taken are 7 different data sets: movie titles, directors, movie ratings, episode genres, and also data. Okay, so this is the example of
So the first step we are going to do is to download and extract files from the datasets like IMDb.com. The second step is that we are going to download the program for the IMDb.com to use the visualization or for the third step, we will import the dataset that we downloaded, and we will use the merge function by using the join table by using the relevant dataset and merge it into the join table. So for the fourth step, we will try to see some data that are not relevant. For example, the null value. For the fifth step, you use the data set and we will pivot to create a graph. We have created like 5 graphs. And we will create the different kinds of graphs to
So now we're onto the analyzing our data set and graph part of the presentation. So first off, this is a graph that we have created from the Tableau desktop. It shows the numbers of films per year, and it shows from the year 1900 up to 2020. So now we're trying to like identify factors in the history, like what affect the movie release to be increased or decreased. So as you can see from 1990, and then in the year of 1929, the first television station in America started broadcasting in 1929. So the number of movie produced started to come up at kind of a linear amount. But then in the year of 1997, that one. In the year of 1997, the VCD or the video compact disc, like the CD player was created, and it became widespread, sold widespread, and then the amount of movie that started to increase exponentially. And then in the year of 2005, 1993, the VCD was released, and then 1997, Netflix was created, and then 2005, YouTube was created. So as you can see from 1993, right, the second like rectangular box, the amount of movies start to go exponentially until, okay, you cannot see, but it's behind that thing. Okay, until the most movie that produced in a year was produced in 2016. But then from 2016 until 2020, the movie then which was produced then came down. Why? Okay, we know that in 2019, right? COVID, of course. But then how about 2016 to 2018? Why did the number of movies start coming down? This is because there's a trend that people start watching streaming platforms more, such as Netflix, HBO, Hulu, and so people now go to the theaters less. So the movie creators they get the income from the theater less. So then they think that okay, if they get less, then they would produce less movie, but they want each movie to be more quality. Okay. This is the number of films in the last 5 years and the percent difference of the number in each year. So first, this in 2000. Okay, so I'll explain very basically. So from the left one, right, it's 2016 until 2020. So the movie started coming down in 2019, and in 2020 it came down like 40%. So yeah, that's because of COVID. Because of COVID, the movie creating process is very hard. So the movie release then reduced like substantially 40%. Okay, so ranking of the actually it's not most what I did wrong. It's ranking of most rated films genre in the year of 2019 and 2020. So the graph is quite complicated, but I will simplify it. So in 2019, right? The number one most rated
movie in 2019 is the adult genre. But then, however, in 2020, the adult genre then came down to number 13, from number 1 to number 13. Why? Because we do not know if this is the exact reason, but we think that like people when they watch adult movie, right, they like to go watch it in the theater. It's a significant one. But however, in 2020, they cannot do that because they cannot go theater. And another interesting fact is 2019, right? The adventure or like the movie that children like to watch is in rank 16. But then in 2020, adventure from 16 came to number 3. Why? Because of COVID-19, right? Kids stay at home. Most kids stay at home and they watch adventure genre. And that's why the adventure genre like came up the ranking 13 rank to rank 8. So next average rating and number of votes. Yeah. So as you can see, the average rating is the blue line, and the number of votes, like the people that go vote on IMDb website, is the orange one. So average rating of a movie, right? Like overall, the movie, they have average rating like 6.8, 6.89 like that. And throughout from 1900 until 2020, right? The average rating of movie goes up. Okay, that's fine. But however, the number of voters on IMDb website, it also goes up. But then as the movie amount of movie release is reduced, the number of voters also come down. But as you can see in this graph, the number of voters doesn't affect the average rating of a movie. So even though people vote for movie less, it doesn't mean that the quality of the movie would lessen. This is the top 5 rated genre and the top 5 genre that was produced from, this is a combination of 2015 to 2019. So the top 5 rated genres are history, music, documentary, sport, and western. However, the top 5 movies that were produced were horror, documentary, comedy, drama, and western. As you can see, like even though the movie that were produced, like the genre that were produced a lot, like drama, comedy, horror, we feel they were the most produced, however, they aren't the top rated. So we can see that like the number of movies produced doesn't affect the number of the quality and the rating of movies. And this is the top 5 movie genre of 2020 and top 5 genre that were produced. So yeah, from 2015 and 2019 combined, compared with 2020, the top 5 rated genre are still the same. Like they're still the same, it's still history, documentary, music, sport, and western. Even though the number of voters came down, however, the top 5 genre are still the same. And the number of genre produced are still the same. So what we can conclude from this is that COVID-19 may reduce the amount of profitability and the amount of movies produced. However, it doesn't affect the ratings or the quality of the movie that much.
On one analysis, we have found that there are different factors that affect the movie. Also, we have tried to define the factor that causes the change in genre watch from 2019 to 2020. We also analyzed the relationship between number of votes and the relationship of 5 server to top 5 motivated chamber between 2015 to 19. Thank you.
Team. Yeah.
Like, what is the purpose of calling the graphic position? Your just don't it's on your own. What have you done? Good.
I mean, analyzing. I mean, if we don't plot the graph, plotting the graph will us visualize the data that we don't know and
Like the ranking, like the opinion, the constitution is like like just the ranking. Like so many look like okay, on this year the ranking is this, and on that year the ranking is this. How can you like okay, like it's the only factor that like ranking. What is the analysis?
it's not yet up to talk. More we need more updated information about the analytics I mean, yeah, so we think that the reason of making nice data is to see the plot pattern. However, to conclude, we need to match it with some of the facts and database on the internet or on the news, or we need to conclude it by ourselves. But that conclusion is not entirely like based on our thoughts, but it's based on the numbers that we can see, and then we match it with some of the news and the situation, and then we analyze it into the logical base. And the reason we need to make the visualized graph is that we can see the numbers, and then we can see the trend of the data. And then, yeah, as I said, we can match with the situations and the news and analysis of the other website or other thoughts of the other people. We can compare them together, and we can make the public analysis. So I think the purpose of the graph is to see the pattern. And then the conclusion, we need to make it by ourselves. Of course, that's the goal. But then we can make it more logical by using just by
As I see your presentation, I see already data visualization on. So what machine learning are you going to use to play on data for prediction or your analysis? Have you ever tried?
Yes.
Or if you have any chance, which algorithm are you going to use it in your?
To be honest, I'll just tell you the truth. We don't know how to do machine learning. Why we use visualization. Okay, but if we have a chance to use machine learning, we would and model that we would use, then maybe we will. Actually, I don't know what we do.
Actually, because like the topic of this project is obvious. I mean, we know that it's because of the COVID, so that there are some changes of the information. So I think we don't need to use the machine, but that's because as I told before, I mean we can match the graph and the current situation together. And because the current situation is so clear that it's COVID-19 and graph, we do not need machine learning to see that because of the COVID. I mean, we can just base on logical thinking. And then to visualize it, we can see as a program that we can see the numbers. Yeah, so I think there's no need for the machine learning. But
We don't need it, but
yeah, but I think in the future we need, not that because we can't do it, but I think because the visual graph is more outstanding and visualized within software. Okay.
it's not really affected by.
Thank you.
Maybe for this graph, I'm tracking both one around. You said would it would for us that earlier about in like what actually line is a typo. What is there's most like yes. So one thing I could suggest about this, if you're facing some genre will usually have a higher rate. If you go to like almost every documentary will have a higher rate. Or and also nowadays genres are really mixed up together. So if you're talking about maybe comedy, you will be maybe both and horror, and that might also be the thing. Because your horror might not go as high as maybe with horror and also comedy. Because IMDb is based on like you. Any more questions?
Okay.
Thank you. Okay, so hello guys, we'll be talking about the relationship between image type and engagement metric. Here's our team members, so take a look at images, remember already, know who we are. Alright, the table of contents. So today we're going to be talking about first the introduction, our information about our data set. Then we're going to be moving on to the problem formulation about our data set, the method that we'll use to tackle our issue. We'll talk about our experiment, our result, and finally we're going to findings inside what we can improve in the future, and also that we can overcome. Alright, introduction.
So our motivation is based on two parts. The first part is like the fact and figure, and second part is the percent engagement and response. For fact and figure, there are 1.2 billion digital users on 2019, or about 1/4 of the world population. And the e-commerce sales growth significantly and become 14.1% of global retail purchase amount. Global market size for 2020 is at $4 trillion. We found out that the top two best selling categories on Facebook are beauty and nature and fashion. In terms of user engagement, we have done the research and found out that Facebook use age range to calculate the profit or the impact of the post. The age range included ethnicity, race, and time decay. We found out that the post and photo or video became more rich. This information is made our group interested in further study more on what is the correlation between the photo and the engagement, and how to use the shop service to gain more engagement by using data from Facebook. So the scope of the study, our group used the data set from the cosmetics and fashion from a retail server on Facebook page. Then we scroll down from data set to data type, and we cover with the audit in.
Okay, so more about our data set. So I said like from 10 Thai fashion and cosmetic retail sellers, and we get this data from the UCI repository. Like this data is donated around in 2019 with a total of 7,050 instances. So like for the attributes of the data, we got the one that is the post information, which are the status ID, the status type, which is like whether it's a link, status, video, or picture, and the status published for the date and time of the post. Then we got the user engagement information, which are the total number of reactions, number of comments, number of shares, and number of like individual reactions. And this is like the picture of our data in the CSV store. So our problem formulation. So in this project we aim to find the relationship and possibly in the future prediction from like the post information, or to give more specific components of image in the post to the useful instant reaction or engagement. And for the methodology.
Well, first, the further methodology, we'll be focusing on classification, but after exploring the data, we found out that many structures we focus on the gathering insight part. So at first, from the data, we clean out, because we only use the positive photo, we clean out positive videos and links, and then we harvest the data using robots. Using the robots, we go to the screenshot it and crop the image out. And then we use that and run into the image to make object detection algorithm to find out what's in the picture. And then for the variables in the data set, we derive more variables from that. And the example of variable we derive is percentage of its version type to the circle. This will be used to find the version distribution that will be used in the cluster analysis. And the method used for cluster analysis is theory. After that, we use a theory algorithm to find the association between different elements in the photo, and we also categorize the item in the photo into categories. And after that, we run this variable in the classification method to train the model to predict the version distribution from the element present in the photo.
Okay, to be more in detail in the process. This is the process of working. Step 1, we will harvesting and cleaning data, which data we searching data set from the UCI. And second thing is we will be going to talk about in detail about in this image processing that we creating bot to screenshot the picture from the Facebook and collecting data that we use. And 3, we will use after we collecting data, we will use that useful data to detect the process and clustering it by using many models to find which one is good with our data set. And the last one is we will talking about the result from a people analysis and the limitation and the future improvement. This is the detailed process of the when harvesting and cleaning data. Step 1, we will download the data from the repository in CSV file, which we have around 7,000 of data. And then we will remove image that type data from including link, data, and video. So we will have only 4,000 around 4,200 data left. And then we will use the robot framework to access the link and take the screenshot of it. And the next step is we will remove the invalid site. Invalid site is including the deleted post and also the private post. So in this step, we will remove unuseful posts, unuseful pictures from 4,000 to 1,800, around that. And then the last step is we resize all the images. So this is the pictures of the code that we use. At the top left is the robot framework that we use to screenshot the pictures, and the top right is how we resize the pictures, and the last one is the object detection.
Okay, first of all, we have to find the tools to do an image processing. Which one that we look up is Google Cloud Vision API. It's free for the first 1,000 picture, and after that it will cost $1.5 per picture after that. So I think it's too costly for the purpose. So then we move to Wolfram Mathematica. For the Wolfram Mathematica, it's pretty good for our project, but our device it don't have that much capabilities to process the information. It takes minutes or to like process each photo. So we decided to use Python because we have Python background and it's free. These are the 4 models that we have gone through. The first one is ResNet. ResNet is an object recognition model. All of these are trained model. First one is basically it asks what is the picture of. It's look the picture as a whole image and then tell us what is the picture of. Some picture when I crop it, I use program to crop it, so it's not that precise crop. So there are sometimes I have some like button, comment button, and share button left, and it recognizes this picture as a website. So it's invalid for our project. So we move to RetinaNet. It's also a trained model too. This one is sometimes we can make it basic by asking them what objects are in that picture, and this is what we need. However, there are some untrained data in the field because we use the image that we process are in fashion industry, right? So they will have person, clothing, footwear, something like that. However, the retina net it doesn't contain clothing, footwear. It can cause something like person, car, umbrella, city. So it's not appropriate. It's not bad, but it's not appropriate for our project. Then we move to YOLO. That's the same problem with retina net. And then the last one that we moved and we decided to use this inception ResNet V2. It's a convolutional neural network or CNN. It has 164 layer deep, and it can classify image into 1,000 categories, and it can detect like the gender of the person in that picture, like and clothing, dress, footwear, and like that. So it's more appropriate for our project. And after we process the image, there are 106 different objects detected. But this graph only shows 14 items that appear more than 1%, which is around 18 times. The most common one that we found is human face. It appears 1,437 times, followed by clothing, women, and then it's dropped down to girls, race, and it's dropped again to footwear, person, and the following thing.
We did a total of 4 different for-ish, we focus on different group of variables. For example, the first clustering we use the count of different non-life actions. And for the second, we use the distribution, which is the percentage of different non-life actions to the total. We found out that the second clustering method to the field. But that's the downside because not every code has non-life actions, so we need to cut that. So this is the code. This is the visualization of the each cluster from cluster method 2. As you can see, the shape of each cluster is not the same, and we find the average of each cluster to get the insight of what each cluster is about. For example, cluster 1 is the distribution with mostly the cluster 2 is mostly bar. Visualization of the same as the previous graph. We use that graph to color to identify which version is it.
For the last one, the experiment that we did, it's about a priori association with mining. Here, what's your mind now have no idea what's a priori algorithm. It is about association rule mining for correlation between clustering and object basket. It's about which objects or which items would come along with another item. For example, when you have X object in the data set, it's about this percentage, but when X comes together with Y, what's the percentage of the item will come together? Here is the code that we use to run the program. And here can give you more ideas what a priori is. When you're looking all the data set, it's about 100% right, and then when you're looking at only clothing, it's only 55% of all the data. And when you separately look at human face, it's about 71% of the data. But when it's come together, it's come together with 45%. But not all clothing
come together with human face. Here's our results, and we ran 3 files, like the difference of clustering of items, and this is one of the results that we ran with. Here are some visualizations that we got from code that we ran it out. You can see that human face, movement, and clothing is top 3 items that we found in items. And here is the association between items that we found out. All of the nodes are items that we mostly find in items, and the ages, it's the association between items.
So you can see here is the result visualized in a graph form. This one is for human face and clothing. Yes, this one is for human face and a woman. And then this one is for clothing and woman. Also, the way this works is it only detects one of each, so either human face, woman, or clothing in like a panel that we have. So, for example, for this instance, it would detect both a woman and also a clothing wearing it.
So this is the categorizing of items I talked about earlier. For example, we put some of the same category into the same basket. For example, accessory will contain items such as sunglasses, handbags, and furniture will be stuff like bed, chair, and table. And this will be used for classification as well. As mentioned earlier, we take really long to harvest the data, so we focus on better insight with unsupervised learning instead. So we did try supervised learning. This is one which kind of thing that we don't. The method we use is random forest, which is decision tree, and we tried on 2 different data sets. The first one is we used to predict 2 classes. One class is posed without any non-regression, and the second class is posed that has like non-regression. For example, love, bar, and angry. This is a confusion metric. As you can see, the precision is below the model machine is not that good yet. With the accuracy of 50%. And for the second distribution, to identify the factor of reaction distribution, which is our main tool. But as you can see from the result, the accuracy.
So to conclude very briefly, the first thing we kind of figured out is that internet traffic, internet traffic will almost always favor posts with recognizable human face compared to those with animal objects, or those of human but no recognizable human face. That's the based on the result we had for our little experiment. And also, we also figured out that different models can have different effects and maybe wise for people to base their decisions on multiple tests. Continue that. All methods, models that we explored with our experiment. For image recognition, we use ResNet. For object detection, we had YOLO, ResNet, and ResNet. For our cluster analysis, there's scikit-learn, clustering K-mean for association and mining.
there's a priori. The classification of student learning there's a whole, and there's probably a lot more that we probably haven't touched upon, haven't looked at.
For the limitation, for the limitation, there's a low rate of reaction to other engagement. And the second one is the things that appear on our object detection, mostly human face, clothing, and women, because we gather the data from fashion and cosmetic. And the third one is the data that we collected is it can be it's in the same period of morning of King Rama 9. So some posts will be a post of King Rama 9. So it might not related to the main content of the page. And by using the screen capturing, some posts may contain a lot of photos, but we recognize them as one photo. And for future improvement, we can improve our supervised learning in our reaction prediction, and maybe we can do more detailed detection for human face, such as sad, happy, or something neutral. And the third one, we can find the correlation of the picture and the post timing. And the fourth one is we can assign the sentiment value or engagement score to cluster to be able to rank which image composition of which cluster is the base. Have to get more customer engagement. Thank you.
สำหรับการเป็นงานคือระดับเรา
Yes. Okay, so let's move. Here, so the first one that we have a problem is GraceNet. As I said, it's look at a whole picture and like detect what is this picture of. It's not like object detection, which will say that what objects are in that photos. Yeah, so we change the model. Because the answer is because that model is not appropriate.
That's like a difference between what's the photo and what's inside.
Okay. Next group.
Our team is no shield. Our team is the content introduction, literature review, data methodology, problem resolution, and okay. One of the greatest magic in the world is music. Is there anyone in here privately listen to the sad song when you are heartbroken? Feel more energy and listen to fast sleep song during exercise? Okay. It's because music makes your brain release dopamine, which makes you really focus and find interesting. There are many research claim that music can change and affect people's mood. Despite all the research, there are many questions that are related. For instance, how does music affect their lifestyle? Is it possible to change people's life with the use of music? Our team wants to find out if music can actually shape people's life in the long run, especially in the past. Our aim is to prove that music can significantly shape people's life and how artists who are in the spotlight and the center of influence should be more responsible to their own content. This may cause one author with more than they could ever imagine. The less in content censorship can eventually lead to more inappropriate actions in people's words and widely the public. Think it could profoundly affect people's behavior and emotion, which is the main concern to all. We are mainly focusing on how the arrival of this inappropriate from music industry correlate with the public actions as a whole.
So in terms of literature review, so we have 4 types of literature review that we focus on. First one is increase in inappropriate work in the music industry. Second one is change of music style, and next one is how music style shape people's life, and lastly is technical of how to detect work online about either profane work or related to stuff. Okay, so first let's talk about the profane. So profane is similar to bad word, so that's like good word. Yeah, that's all. So this guy, Salim Sufian, so uh, okay, so you know that. So using the technique called talk keyword. So basically, he just had the repeated words such as a and the, and furthermore out, and see that how many words that came up, which one is more popular, and he see that each year there are approximately 1.3% annual using appropriate word. Next one is doing the same thing, but actually quite similar, but he detecting furthermore by detecting up to 3 things, which is unique word, total word, and also number of songs that came up this year. So this is a little advanced from the last one. Next one is changing music trend. So we have noticed that rap music coming into our life more and more. In the past, we engaged rock and those pop music, and yeah, right now we are rapper. Next one is behavior related. As your book mentioned that, your book already mentioned that music can change people's emotion and make people feel the same way as music. But in the long run, it's pretty hard to say. We have seen music in marketing like Gucci Gang and Gucci Girl, those things that we see that there is marketing related to music and music may can force people in the long run, but there are no strong evidence yet, and we try to prove that. We try to prove furthermore because we know that national athletes and those things make people love their nation, but we haven't like have strong evidence about the this kind of music that shape people in the bad way. So this here is what we're trying to do. And increasing profile watch, which I already said. This one is the first experiment that we're doing. It's actually the profile watch increase and we prove that it's wrong somehow, and Mata will present how we're going to do that. Okay, so this one is by this guy. So he explaining how is the band detecting the drug activity signal. So basically, they ask for like expert in many field and also manually detecting and then give the machine knowing that this thing is like drug activity, but it's pretty hard because as they're detecting mostly the drug activity already done. So it's pretty much not useless, but almost. Yeah.
For our project, we want to detect the draft related words and backward related. We divide our work into three parts, which are the gather the data, keyword detection, and summarize the result. For data preparation, we need to collect two things. First is the song lyrics from each year. For this project, we use the top 50 songs in Billboard Top Chart in year 2014 to year 2018. To collect this, we need to go to billboard.com, search for the top 50 songs name, by lyrics, copy them into one file per year, and as you can see on the slide, and save it as .txt. The second set of data is keywords that we use to detect. In this project, we have to collect two categories of words, which are drug-related and bad words. For the drug-related words, we got it from American AddictionServer.org and ReverseDictionary.org. After we got the drug-related words, we found out that there are some words that are not related to drugs. For example, hope and treat. So we screen and sort unrelated words out. And after that, we got 110 words in total. And you can see some of the words on the slide. For the backward keywords, we use the 1,200 words from Facebook. It's like the list of the words that Facebook banned into user tracking. Next is the detection code. For the top, we have to make the program open and read our file that contains the lyrics and convert the uppercase to lowercase letters. Then we input the keyword that we want the program to count and make out in line 9 to 11. Then print the result, and you can see the what the result look like when we combine all. You can see what the result look like in the right hand side. And then we have to combine all the numbers for each year. After we combine all the numbers each year, and because some song may repeat the same phrase and some are short and long, so we take the word we divide it by total words and calculate it in the same, as you can see in the table.
So next we're going to talk about the problem that we face. So the first the problem that we face is that the song used idiom instead of the normal word. For example, my cup of tea. It didn't mean the actual cup of tea, but it means another thing. So the next problem we face is double meaning. For example, the lyrics from the song name whistle. So the song goes, can you blow my whistle, whistle, and you let me know, I'll show you how to do it. Okay, so when the song say blow my whistle, it didn't mean blow the actual whistle, but it means blow jobs. Oh yeah. So the next problem we face the word in the song is very different, but means the same thing. For example, marijuana can adapt to dab, dank, or and many more. And the word in the song may be shortened for example to M. And data collecting, data collecting. So the data that we get is not it's not the all the data that we get the analytics data, which is not all the data. So and so the final problem we face the quality of the data. Like we cannot find the number of components I found. So this is another the method that we have to use, but have the problem using it. Because the problem that we cannot use this method is because the song that we use is from the Billboard Top Chart, and the song is not English. Some of the songs are Spanish, so we have to use other set of data to detect the bad words and rough words. And the other problem that we cannot use is called the language complexity. The language complexity is like the thing that I said in the previous slide, the idioms, double meaning, adaptation, and shorten. And the final problem is about the fragmentation. We don't have time to understand the method completely. So we cannot build a solution that says in this previous slide. I use the command to open the text from the for words and read it and change it to the list. And we also open the song on the Billboard top chart. In this example, I use the 2018 song list. Next, I create the variable counter and give it 0. So when the list of song in the list of lyrics and list of bad words counter together in the same, the counter variable will +1 and the unit counter to get together.
Okay, so this is our outcome from our work. So the first one is related of bad word, appropriate word, and crime rate. So this one is not related at all. We think that as we research, secondary research, we say that profane word don't actually relate to crime, but actually we use bad word in a good way more than in a bad way. So more of cracking joke instead of offense, other like something like that. So that is like more of a joke way than offending other people. So it has nothing to relate to crime rate. As it is administrative crime rate is actually related to GDP. As ECT is richer, that's less crime rate. So here, the right one is crime rate and no correlation. Okay, so this is like a little example of crime rate and economic that I mentioned. So yeah, there you go. Second one is the drug activity related to drug work that we detect. So the blue graph is the drug related work that we detect. The first one on the left-hand side is drug arrest, and the right one is the direct death by drug. So it's actually hard to say that music have like power on people decision to take a drug, because first of all, drug arrest doesn't mean that people can take more drug. It actually means that they can catch more people with drug. Yeah, that's all. Because like it's hard to say that how many people taking more drug when the government can say that. So hard for us. So the next one that we using is death by drug. So death by drug is actually mean death by drug, not people taking more drug. Like if I start taking drug 10 years ago and I just like one day I just like feel very hard and overdose it that day. It doesn't mean that I listen to rap music and I just like putting in more. Yeah. So that's our outcome. So key takeaway. So music is very hard to analyze, and we say that lyrics alone and like just a language alone is have very variety of field, like language. If for just America they have like Latin, like Spanish and America, which if we want to like really understand it, we have like instead of data set. And furthermore, like different type of music, which we have to do type for each type of music again, which is just too much. And can't think that about like the vibe of music. We cannot say that if they mention about just one time, that's about doesn't make people like saying that. Unlike like if one song say about rap 10 times, it doesn't mean that people will take more drug because of the song and just another song that taking talk about drug as well. So that is like the thing that we cannot analyze. Next up is what we can improve on this project. So first of all, add music from each year. We might add like another 100 more for each year. So we have bigger data set, but I don't think it's necessary because top 50 is like have very cut between top 50 and like other top from the board. So we think that top 50 is enough. Another one is we take work manually. Many think that this one is like waste of time, but people actually doing this thing because it's very hard to understand the word. As I said, sometimes easier to just like watching the they just analyze this up. Third one is hierarchy of each bar, which we cannot do. As I mentioned, one song mentioned just on the doesn't mean that this is open and open properly. Yep, that's all. Thank you. To be honest, I don't think this is great. We think that this area is too hard for me. Like even the professional cannot do it. So it's hard to say that it's related just because like this increase and activity increase. So it's many other factors that, as I said, that then maybe like economic factor that happen to relate to this thing. So we don't think that we can summarize everything.
Can you go back to the
So there's a graph with secondary. So this thing is just like detective layer of program basic graduate. No. This. But this is like fourth grade. Fourth grade. Not total standard.
So what is the
Any more questions? Don't be shy to ask. Anyone else? Oh, I'm just kidding.
Like we detecting, we try, and this is not, we try to like detecting the word that we put it up, so we have to learn first. Oh, I have to call again. So first, and put in the lyrics, and then detect it, and then analyze. So in terms of machine learning, we will talk about that. So as I mentioned that from this part, so this is actually the role model for our so we basically plug in all the drug activity that they detected manually through like machine learning, but we cannot do that because we don't really understand this is especially that would abstract for us, like to dig down each ethnicity like to the knowledge. Like just even like in rap or party, you cannot analyze that.